Hello everyone. In this video, we'll be talking about the most beautiful concept of the trigonometry, the trigonometric ratios and the trigonometric functions or the circular functions. This video is going to be extremely useful for all physics students because in many physics chapters, we require the values of sine function, we require the values of cosine function. Okay. So we will start with the trigonometric ratios, then we'll develop the theories for the trigonometric functions or the circular function. We'll prove that sine function and cosine function are periodic. Mostly these two functions are used in physics, so we'll focus on them. Then we'll derive few important relations, and for conceptual practice, you'll get a checkpoint in this video. The answer of the checkpoint can be verified at the end of this video. Okay, so let's begin. Look at this right triangle. The largest side of this right triangle is named as the hypotenuse. Now, can you name the remaining two sides of this triangle? Let me know in the comment box. The correct answer is, until we know the theta, we cannot name the sides of this right triangle. So, in next picture, I am giving you the theta. Now, can we name the remaining sides of the triangle? It's easy. The side which is closer to the angle theta is known as the adjacent side, and the side which is opposite to the angle theta is known as the opposite side. Is it okay? Now I am changing the location of the angle theta. Can you name the adjacent side and the opposite sides again? Correct. Looking at this diagram, I hope you got the correct answer. Few students do mistakes in taking the sides. So you should specially pay attention where the angle theta lies. Close to that, there is the adjacent side, and opposite to that, as usual, there will be the opposite side, and the largest side of the right triangle will always be the hypotenuse. Okay. Now we can see 6 basic trigonometric ratios on the screen, namely the sine, cosine, tangent, cotangent, secant and cosecant. For simplicity, the sine is abbreviated as SIN, and similarly you can see the remaining abbreviation. If you look carefully, the word sine and cosine, they are similar kind of words. Why? Any guess? Actually, cosine means the sine of the complementary angle. Similarly, the cotangent means the tangent of the complementary angle. Cosecant means the secant of the complementary angle. And what is the definition of the complementary angle? For a given angle pair, if the sum of the angles is 90 degree or pi by 2 radian, then these angles are known as the complementary of each other. For example, 30 degree and 60 degree. If we sum up this pair, then 30 degree plus 60 degree result into 90 degree. It means 30 degree and 60 degree are the complementary angles of each other. And further it means sine 30 degree will be equal to cos 60 degree, or vice versa. Cos 30 degree will be equal to sine 60 degree. Similar relations we can obtain for other cofunctions. Clear? Now, if you pay attention to the board, here is a condition written for theta. The theta must be greater than 0 degree and should be less than 90 degree. Pay attention, the ratios which are visible on the screen, they are useful if and only if theta is greater than 0 degree and theta is less than 90 degree. Okay. Suppose if someone asks us, find the value of sine of minus 30 degree. You cannot use these ratios to obtain that answer. Someone asks you, tell the value of sine 0 degree. Using this definition, using these ratios, can you find the value of the sine 0 degree? Think about it. Try to draw the diagram. If you wish to take theta is equal to 0 degree in the right triangle, can you form a triangle actually? Think about it. If the theta is 0 degree, it means the length of the opposite side will become 0 and the hypotenuse and the adjacent sides will be collinear. Then there will not be any triangle. So you cannot use the definition of these ratios. Getting the idea? the value of sine 0 degree, cos 0 degree, tan 0 degree and so on cannot be obtained using these ratios. Now suppose if you want to obtain the value of sine 90 degree, means you want to make theta is equal to 90 degree. Can we use these ratios to obtain the value of sine 90 degree? Think about it. In right triangle, there can be a single angle whose value is 90 degree, because if you wish to make the other theta also as 90 degree, then it won't remain a triangle. So it clearly indicates that these ratios are valid if and only if theta is greater than 0 degree and less than 90 degree. For negative angles, for angles greater than 90 degree, we cannot use these ratios. It indicates we need a better definition for the sine, cosine and the remaining trigonometric functions. For that, we'll lay down the framework in the next part of this video. Before that, I would like to talk about the positive angle as well as the negative angle. Suppose we take up the Cartesian coordinate system and there is a revolving straight line OP. If the straight line OP revolves in the anti-clockwise direction, then the theta is always taken as positive, and if this straight line OP revolves in the clockwise direction, then theta is taken as negative. This is a convention which we will be following continuously in this video. Okay, so let's go further. Now we are going to define a unit circle, and using this unit circle we'll be defining the trigonometric functions or circular functions. Let us take up the Cartesian coordinate system, the x-axis, y-axis, origin, everything is visible on the board, and now we construct here a unit circle. Unit circle means a circle whose radius is 1. So according to this diagram, the center of the circle lies at the origin of this Cartesian coordinate system, and the equation of this circle is x square plus y square is equal to 1. The radius of the circle is 1. You got it? This unit circle is a pretty powerful tool. Why? You'll understand it in few minutes. Suppose in this unit circle we construct the right triangle again as shown. The theta is given here, so we can take up the adjacent side, opposite side, and the length of hypotenuse here is how much? 1, because the radius of the circle is 1. Okay. Now using the old definitions, using the ratios, how much is sine theta in this right triangle? If we pay attention, the coordinates of point P are marked as x comma y. So what will be the sine theta? Sine theta will be the opposite side divided by the hypotenuse, and the length of the opposite side is equal to the y coordinate, and length of hypotenuse is 1. So the sine theta will be equal to y by 1. Do you agree? Similarly, I am going to find the value of the cos theta. The cos theta is equal to what? Adjacent side divided by hypotenuse. The length of the adjacent side is equal to x, and the length of the hypotenuse is 1. So how much is cos theta? Simple, x by 1. Now suppose if I delete the triangle from this picture, even then these definitions are valid. If point P has the coordinate x and y, which is lying on the circumference of the circle, then x is indicating the value of cos theta and y is indicating the value of sine theta. So tan theta will be equal to sine theta by cos theta, means equal to y by x. See, now the title of the topic on the board, it is trigonometric function or the circular function, because a function gives output for every input. So here for every theta we will have the x and y coordinates on the circumference of the circle, and we can find the values of corresponding cos theta, sin theta, tan theta, all the trigonometric ratios. That's why we are now naming the things as a function, trigonometric function or circular function. Clear? So whether that right triangle is inscribed in the circle or not, this definition remains valid. On a unit circle, the value of the x coordinate will give us the cos theta and the value of y coordinate will give us the sin theta. Let's see the power of this unit circle. Suppose the point P is lying on the x-axis. Okay, what are the coordinates of the point P? I hope you know that we write coordinates in the order. First we write the x coordinate and then we write the y coordinate. So how much is the x coordinate of point P? 1. It is lying on the x-axis. And how much is the y coordinate of point P? 0. Y coordinate actually means how much up or down you are from the x-axis. So right now the point P is on the x-axis itself. So up and down from the x-axis is 0. So y coordinate is 0. Now look back at the definitions. What was the sin theta? Sin theta was the y coordinate, means sin 0 degree here will be equal to the value of y coordinate, which is equal to 0. So the sin 0 degree is equal to 0. I hope you understand the logic. And see, there is no triangle with the 0 degree, but using the unit circle we can obtain the value of the sin 0 degree. Now let me ask you, what is the value of cos 0 degree? What should be your answer? Simple, cos 0 degree means x coordinate and x coordinate here is 1. So the cos 0 degree is equal to 1. How much is the tan 0 degree? Tan 0 degree is equal to y coordinate by x coordinate, means 0 by 1. So the answer is 0. I hope you understood how we are getting the value of sin 0 degree as 0, cos 0 degree as 1 and tan 0 degree as 0. Okay. Now we'll go for the angle 90 degree. See the diagram again. Can you tell me the coordinates of point P this time? It's simple. Point P is lying on the periphery of the unit circle and now the point P is lying on the y-axis as well. So the x coordinate of the point P is 0 and its y coordinate is 1 because the radius of the circle has been taken as 1. Okay. X coordinate gives us the value of cos theta. It means cos 90 degree should be equal to 0. And y coordinate gives us the value of sin theta. So the sin 90 degree is equal to 1. Is it okay? And if you want to obtain the value of tan 90 degree, tan 90 degree will be y coordinate by x coordinate. So it will be 1 by 0, which is undefined. Fine. What should be my next question? Correct. We should go for the angle 180 degree and look out for the values of cos 180 degree, sin 180 degree. So moving for the next diagram. Now the point P is lying on the negative x-axis. Can you tell me the coordinates of point P? Brilliant. The x coordinate is -1 and the y coordinate is 0. It means the cos 180 degree will be equal to -1. And the sin 180 degree will be equal to 0 because the y coordinate is 0. Okay, see how easy the things are if we define the trigonometric functions using this unit circle. Okay, what should be the next target? Correct, the 270 degree. Now the coordinates of point P are x coordinate is 0 and the y coordinate is -1. It means cos 270 degree will be equal to x coordinate, which is equal to 0, and the sin 270 degree will be equal to -1. Fine. Let's go to the next point. The angle becomes 360 degree. For 360 degree, we can easily say the coordinates are similar to the point when the angle theta was equal to 0 degree. It means the value of sin 0 degree and sin 360 degree will be identical. The value of cos 0 degree and cos 360 degree will be identical. Similarly, the value of tan 0 degree and tan 360 degree will be identical. It indicates sin 360 degree will be equal to 0 and cos 360 degree will be equal to 1. Okay, I hope you liked this method. Let's explore few more things. I'm going to derive the Pythagoras theorem in a beautiful way. The equation of the circle is written as x square plus y square is equal to 1 square. What is x here? The adjacent side in this triangle. What is y here? Opposite side. And what is 1 here? The hypotenuse. So if you pay attention, x square plus y square is equal to 1 square is actually adjacent side square plus opposite side square is equal to hypotenuse square. That's the Pythagoras theorem. See the beauty of the unit circle. Okay, let's go further. Now we are going to derive these three important trigonometric identities. If you wish, you may pause the video here and give it a try yourself. I hope you all got the correct results. Let me derive them. We have the equation of circle as x square plus y square is equal to 1. Do you agree? What is x here in the unit circle? Cos theta. And what is the y here? The sine theta. Put these values in the equation of the circle. So cos square theta plus sine square theta is equal to 1. The first trigonometric identity. Simple derivation. And it is Pythagoras theorem also. Okay. We are going to derive the second trigonometric identity. The equation of the unit circle is x square plus y square is equal to 1. Divide the entire equation by x square. So the equation will look like 1 plus y by x whole square is equal to 1 by x square. What is y by x? Tan theta. So put up that value. Now the equation will become 1 plus tan square theta is equal to secant square theta. The next trigonometric identity. Got it? You may note it down, then I'll derive the third one. For third trigonometric identity, we'll take up the equation of the circle again and let me know what we should do. We should divide the entire equation by y square. So the equation will become cot square theta plus 1 is equal to cos x square theta. I hope you understood it. Note it down, then we'll go further. I hope you all remember the famous ASTC rule. People learn it by the different phrases after school to college, or add sugar to coffee, or all stations to central. This rule says if theta is greater than 0 degree and less than 90 degree, all trigonometric ratios are positive. It can be easily explained using the unit circle. How? For theta greater than 0 degree and theta less than 90 degree, the x coordinate as well as the y coordinate are positive. So all the trigonometric ratios will return the positive values, because sine theta is equal to y coordinate, y is positive. Cos theta is equal to x coordinate, x is positive. Tan theta is equal to y by x, both y and x are positive. Cot theta is inverse of the tan theta. Similarly, you can find all other remaining trigonometric ratios. They all will return the positive values. Let's move to the second quadrant. Theta is greater than 90 degree but less than 180 degree. For second quadrant, we know that x coordinate is negative and y coordinate is positive. It means in the second quadrant, the sine theta and cosec theta will be returning the positive values, and remaining four trigonometric ratios will return us the negative values. Getting it? Moving further to the third quadrant, when theta is greater than 180 degree but less than 270 degree. In third quadrant, the x coordinate is negative as well as the y coordinate is negative. So the tan theta and the cot theta will return us the positive values. Remaining four trigonometric ratios will be negative. And the last fourth quadrant, when the angle theta is greater than 270 degree and less than 360 degree, the x coordinate is positive but y coordinate is negative. It means cos theta and sec theta will give us the positive values in the fourth quadrant. Remaining four trigonometric ratios will give us the negative values. I hope you understand it. You can note down this information, then we'll proceed further. Now we are going to find the values of sine 45 degree, cos 45 degree, tan 45 degree, etc. For that, we inscribe a right triangle in the unit circle as shown. The adjacent side has a length x, the opposite side has a length y, and the hypotenuse has a length equal to 1. Is it okay? In this right triangle, one angle is 90 degree and remaining two angles are 45 degree each. If these two angles are equal, then the length of the sides opposite to these two angles will also be equal. This is a property of triangle. I hope you remember that. It means the x should be equal to y. If x is equal to y, feed it in the equation of the circle. What we will get? X square plus x square is equal to 1, means 2x square is equal to 1. Simplifying this, x will come out to be plus or minus 1 by root 2. Since right now we are in the first quadrant, we'll accept the value of x as plus 1 by root 2. Okay. If x is plus 1 by root 2, it means y is also equal to plus 1 by root 2. And the value of sine theta is equal to the y coordinate, means sine 45 degree should be equal to 1 by root 2. The value of cos theta is equal to x coordinate, and x coordinate here has a length 1 by root 2. It means cos 45 degree is also equal to 1 by root 2. And tan theta is equal to sine theta by cos theta, means y coordinate by x coordinate, which will result into 1, means tan 45 degree will be equal to 1. Now we will be finding the value of sine 30 degree, cos 30 degree, tan 30 degree, sine 60 degree, cos 60 degree and tan 60 degree. For that we are inscribing an equilateral triangle inside the unit circle as shown. Is it okay? Each side of this equilateral triangle has the length equal to 1 and each interior angle is equal to 60 degree. From point P, I am dropping a perpendicular on the x-axis. Then it will bisect the horizontal side of the triangle. Do you agree with that? Now focus on this yellow triangle. For this yellow triangle, the horizontal side has a length equal to 1 by 2. The hypotenuse has a length equal to 1. Then can we find the length of the vertical side of this triangle? It's easy. You can use the Pythagoras theorem. Correct. Using the Pythagoras theorem, this length comes out to be root 3 by 2. Now in this yellow triangle, we can easily find the values of all the trigonometric ratios, such as we wish to determine the value of cos 60 degree. It will be equal to what? Adjacent side divided by the hypotenuse. So cos 60 degree will be equal to half. The sine 60 degree will be equal to opposite side divided by the hypotenuse. So it will be equal to what? Root 3 by 2 divided by 1. Okay. Actually these values can be easily obtained using the unit circle also. How? Look at the point P. Its coordinate are x comma y. And what is the value of x right now? 1 by 2. And what is the value of y? Root 3 by 2. And x coordinate gives us the value of cos theta. It means cos 60 degree is equal to half. And y coordinate gives us the sine theta. So sine 60 degree will be equal to root 3 by 2. I hope you understood this information. Now, can you find the value of cos 30 degree, sine 30 degree, tan 30 degree using the trigonometric ratios? It's simple. I hope you all get the correct answer by doing your calculations. You will find an interesting pattern in these values. The sine 30 degree is equal to cos 60 degree and the cos 30 degree is equal to sine 60 degree. Similar things are valid for tan and cot and sec and cosec. Why this is happening? Can you tell? Actually, the sine and cosine, if you remember, we had the talk, the word co here stands for complementary. Cosine means sine of the complementary angle and 30 degree and 60 degree are the complementary angles of each other. Okay. So we can generalize this as the formulas. Sine theta is equal to cos of 90 degree minus theta, or cos theta is equal to sine of 90 degree minus theta. Similar general formulas we can write for the remaining trigonometric ratios. Getting the idea? Here theta can be any angle. You can put the values and you can verify it yourself. You can note it down and then we'll go further. Now we'll try to determine the values of sine 120 degree, cos 120 degree and tan 120 degree. Look at the point P. Can you tell the coordinates of point P? It's easy actually. The x coordinate of point P will be minus 1 by 2 and the y coordinate of the point P will be equal to root 3 by 2. Okay. So the cos 120 degree will be equal to x coordinate is equal to minus 1 by 2 and the sine 120 degree will be equal to y coordinate is equal to root 3 by 2 and the tan 120 degree will be equal to y coordinate by x coordinate, which will be equal to minus root 3. I hope you get it. Let us try it again. Would you like to give it a shot? Let me know in the comment box what answers you are getting for sine 135 degree, cos 135 degree and the tan 135 degree. Okay, correct. The sine 135 degree comes out to be 1 by root 2. Cos 135 degree comes out to be minus 1 by root 2 and the tan 135 degree comes out to be minus 1. Okay, simple and easy answers, because in this case the coordinates of point P are minus 1 by root 2 comma 1 by root 2. Fine, good. Now I am leaving it as a homework to you. Find the value of sine 150 degree, cos 150 degree and tan 150 degree and then let me know the answers in the comment box. Okay. Now we can see few general formulas on the screen. Sine 180 degree minus theta is equal to sine theta, cos 180 degree minus theta is equal to minus cos theta and tan 180 degree minus theta is equal to minus tan theta. These can be verified very easily. For example, sine 120 degree is equal to sine 60 degree is equal to root 3 by 2 and sine 120 degree can be written as sine 180 degree minus 60 degree. Do you get this? Similar things you can verify yourself. I am leaving it to you. Pause the video here, take your time, put up any value of theta and verify these formulas yourself. Okay, then we'll go further to the third quadrant. Obtain the value of sine 225 degree, cos 225 degree and tan 225 degree. Smart students, I think, can directly answer without any calculations, without any computations. Or otherwise you may pause the video here, take your time and then give it a try. Okay, first of all, as usual, we'll be writing the coordinates of point P. This time the x coordinate of point P is minus 1 by root 2 as well as the y coordinate is also minus 1 by root 2. It means sine 225 degree will be equal to minus 1 by root 2 and the cos 225 degree will also be equal to minus 1 by root 2 and the tan 225 degree is equal to y coordinate by x coordinate, which will be equal to 1. Do you get this? And then you can see few general formulas. I request you to verify them yourself using the unit circle. It can be done very easily. Here theta can be any angle in all these general formulas. Okay, note it down. Then we'll go to the fourth quadrant. Suppose we wish to determine the value of sine 300 degree, cos 300 degree and tan 300 degree. If you wish, you can pause the video here and quickly post your answers. Okay, to obtain the answers as usual, first of all we'll get the coordinates of point P. This time the x coordinate of point P will be equal to 1 by 2 and the y coordinate will be equal to minus root 3 by 2. It means cos 300 degree is equal to x coordinate is equal to 1 by 2 and the sine 300 degree is equal to y coordinate is equal to minus root 3 by 2. And the tan 300 degree will be equal to y coordinate by x coordinate, which will be equal to minus root 3. I hope you got the same values. And now here you can see few general formulas for any angle theta. You may put up some values and verify them yourself. Clear? Note it down, then we'll go further. Suppose someone asks us the value of sine 390 degree. How much is that? Actually sine of 360 degree plus 30 degree, and it is lying actually in the first quadrant. So sine 390 degree is technically equal to sine 30 degree. Cos 390 degree is technically equal to cos 30 degree. Tan 390 degree is equal to tan 30 degree. I hope you understand this thing. So using the unit circle, we can find the values of the trigonometric functions of any angle theta. I hope you got it. Note down all these important formulas and then we'll proceed further. Now suppose we have a question, find the value of sine minus 30 degree. How to do that? The minus 30 degree angle will be lying in the fourth quadrant. So we will try to obtain the coordinates of point P. So the sine of minus 30 degree is actually equal to y coordinate, and the y coordinate is minus 1 by 2. So sine minus 30 degree is equal to minus 1 by 2. I hope you get it. If someone asks us the value of cos of minus 30 degree, cos of minus 30 degree is actually equal to the x coordinate, and x coordinate here is root 3 by 2. So cos minus 30 degree is equal to root 3 by 2. You can verify it. Cos of minus 30 degree is equal to cos 30 degree. Sine of minus 30 degree is equal to minus sine 30 degree. Now what is the value of tan minus 30 degree? It's simple actually. You can let me know. Tan of minus 30 degree will be equal to the y coordinate by x coordinate. So answer will come out to be minus 1 by root 3. I hope you understood how to obtain the values of the trigonometric functions for the negative angles. Few similar questions you will get in the checkpoint. Okay, note it down, then we'll proceed further. Here we have a simple question. Find the value of theta such that sine theta is equal to 1, and a condition is mentioned that theta lies in between 0 degree to 180 degree. If you wish, you can give your quick answer. Correct. The answer is theta is equal to 90 degree. See, sine theta is equal to the y coordinate, and y coordinate here should be equal to 1. So if you consider the range 0 to 180 degree, then in the unit circle, how you will get the y coordinate 1? The simple thing, the point P should be lying on the y axis. So the correct answer is theta is equal to 90 degree for the given range. Okay, let me change the range of the question. Suppose the value of the theta lies in between 0 degree to 360 degree. Then what will be your answer for this question? Correct. Again the answer will be theta is equal to 90 degree only, because for the range 0 degree to 360 degree only there is one position where the y coordinate is equal to 1, that is the point P as shown in the diagram. I hope you understand it. Okay, let me flip the question little bit more. Suppose this time the value of theta lies in between minus 360 degree to plus 360 degree. Then find the theta such that sine theta is equal to 1. Now pay attention and try to post the correct answer. Okay, this time we will get two answers. The first answer is theta is equal to 90 degree, and the second correct answer is theta is equal to minus 270 degree. It was a nice question. You note it down. Then I'll present similar question for the cos function. If the theta lies in between 0 to 180 degree, we need to find the value of theta such that the cos theta is equal to 1 by root 2. You may pause the video here and do the quick calculations yourself. Okay, the correct answer is theta should be equal to 45 degree, because if cos theta is equal to 1 by root 2, it means the value of the x coordinate should be equal to 1 by root 2. Getting it? And looking at this diagram, there is only one possibility for that. Okay. Taking up the second variant of this question, Suppose the range of the theta is given from 0 degree to 360 degree, and then you need to find the value of theta such that cos theta is equal to 1 by root 2. Now post your answer in comment box. Correct. This time we will be getting two correct answers. The theta is equal to 45 degree as well as theta is equal to 315 degree. Okay. Let me change the question a little bit more. Suppose the range of the angle theta is given from minus 360 degree to plus 360 degree. Then we need to obtain theta such that cos theta is equal to 1 by root 2. Now give a quick answer. Okay, this time the correct answers are 4. Theta is equal to 45 degree, theta is equal to 315 degree, theta is equal to minus 45 degree as well as theta is equal to minus 315 degree. I hope you understand all these answers. So it's very powerful tool, the unit circle. Few more questions I'll present in the checkpoint for your conceptual practice. I hope you'll enjoy them. Okay. Using the unit circle for all the standard angles, the data lies here. I request you to pause here and play with this set of data. Draw a unit circle and try to obtain few of these values yourself. Then we'll be going with the periodic nature of the cosine function as well as the sine function. We'll talk about their period and the graph. Okay, note it down. Since we have the various values for the cosine function as well as the sine function, so we are trying to plot the graph for them, taking the theta on the horizontal axis and taking the sine theta on the vertical axis. And we will mark few important points. If theta is equal to 0 degree, what is the value of sine theta? We know that 0. If theta is equal to 90 degree, what is the value of sine theta? 1. If theta is equal to 180 degree, the value of sine theta is 0. Theta is 270 degree, the value of sine theta is minus 1. Actually, this curve is never ending. After every 2 pi radian or 360 degree, the curve will repeat itself. It means the period of the sine function is equal to 2 pi radian. Why the graph lies in the limits minus 1 to 1? Can you tell? Because sine theta was obtained using the y coordinate and maximum value of y coordinate in our unit circle was equal to 1. Okay, and the minimum value of the y coordinate in our unit circle was equal to minus 1. So the graph of sine theta is bounded in between minus 1 to 1. For example, if someone asks you, can you find a theta for which sine theta is equal to 2? Is it possible? No. Sine theta's maximum value is 1 only. Sine theta's minimum value is minus 1. So all the values of sine theta will lie in between these values only. You can never get sine theta is equal to 2. You can never get sine theta is equal to minus 2. You can never get sine theta is equal to minus 5. You can never get sine theta is equal to 10. I hope you understand this thing. Okay. This sine function or the cosine function will be used extensively in the physics. The chapter waves, the chapter oscillations, the chapter electromagnetic induction, electromagnetic waves, alternating current. You may note it down. Then we'll go for the cosine function. As we plotted the values for the sine function, in the same manner we are plotting the values for the cosine function. When the theta is equal to 0 degree, the value of cos theta is equal to 1. When theta is equal to 90 degree, the value of cos theta is equal to 0. Theta is equal to 180 degree, the value of cos theta is minus 1. Theta is equal to 270 degree, the value of cos theta is 0. And theta is equal to 360 degree, the value of cos theta is again equal to 1. So the cosine function is also a periodic function. Its period is 2 pi radian or 360 degree. After every 360 degree or 2 pi radian, the graph will be repeating itself. Here also the maximum value of cos function is 1 and the minimum value of the cos function is -1. Can you tell me the reason? Correct. We obtained the value of cos function using the x coordinate of unit circle. And what was the maximum possible x coordinate of that unit circle? 1. What was the minimum possible coordinate of that unit circle? Is the -1. Cosine function is also a periodic function. I hope you understand all of these informations and you liked this video. Stay awesome. Take care. And if you want to explore more beautiful concepts, you can check the remaining playlists. I hope you'll enjoy them.